All right, welcome back. Module 3. Let's start working with everything we've done so far. So we've talked about drug expressions. We've talked about how they're packaged and how they're described. So how do we figure out what do we want to give to a patient? Let's take a quick look at a single dose calculation. These are pretty easy. Some drugs have a prescribed dose. So an example might be glucagon. Above and below 25 kilograms, it's either 1 milligram or 0.5 milligrams. There's just two choices, But some drugs are prescribed based on a specific patient weight. So here's an example we'll work with. Calculate the dose of epinephrine for a 40 kilogram patient. So according to our allergic reaction medical directive, that's the one we're going to use for this example. The dose of epi 1 to 1000 is 0.01 milligrams per kilogram to a maximum of 0.5 milligrams. Epi is supplied 1 milligram in 1 mil. So we have all the tools available to us to figure out the solution to this problem. So let's figure out our drug first, the weight of drug we want to deliver. So right out of the protocol, 0.01 milligrams times our patient weight, which is 40 kilograms. That should equal 0.4 milligrams of drug, of epi 1 to 1000 to give to that patient. Now what's the fluid volume? It's easy math to get to the fluid volume because we know it's 1 milligram in 1 mil. So we're going to deliver 0.4 milliliters of fluid, which will be 1 to 1000 epi, and we'll get our desired dose. That's it. That's all you need to do. We already did an example earlier of lidocaine, and we figured out how much lidocaine to give to an 80 kilogram patient. So we've already done this. We've done this a couple of times. We're not going to bother with a question for you to do on your own because we've done this a couple of times now. Let's move right on to IV infusions. This will be our last topic for the day. Drip rate calculations. Before we can calculate anything at all, we need to figure out what kind of drip set we're using. And there's kind of 2 or 3 common drip sets used in the pre-hospital environment. 10 drops per milliliter, 15 or 60 drops per milliliter. 10 and 60 are probably the most common. You may find a 15 hidden in there somewhere. Just when you're unpackaging your drip set, make sure you note exactly which one you have. In each case, the number of GTTS, I'm just going to say drops from now on, indicates the number of drops that equal a single milliliter of fluid. So in case you've forgotten, the number of drops indicates the number of drops that equal a single milliliter of fluid. So of our 3 examples, 10 drops per mil means 10 individual drops through that drip set will equal 1 milliliter of fluid. And be sure which one you're using, as I said before. I think most of us could hold up a 10 set and a 60 set and be able to tell them apart. But 10 and a 15 set cannot be easily distinguished, so make sure you know what you're working with. So determining a desired drip rate is a standard formula. And you already learned this at ACP school. I know you did. The formula is amount to be infused in milliliters times the drip rate, or the drip set in drops per milliliter, divided by the time in minutes. And the result of our formula is going to be drops per minute. So here's an example. What is the drip rate for 600 milliliters of fluid to be administered over 1 hour? Now, of course, I chose 600 mils to make the math easy for our example. So, here's our formula. 600 milliliters times our drip set. So I'm going to use a 10 drop set. Again, I'm trying to make the math easy. All of that divided by our number of minutes, which happens to be 60 in this case. I'm telling you, I like easy math. Let's work it out anyway long. So 600 milliliters times 10 drops will equal 6,000 drops divided by 60 minutes equals 100 drops per minute. 100 drops per minute, or if you divide that by 60, we get 1.6 drops per second. So there's your answer. Here's your turn. What is the initial dose of dopamine for a 100 kilogram patient, and what is the drip setting for that dose? Yikes. There's a lot of math involved in this, but I know you already know how to do this. But let's work it out anyway. The first part of that calculation is pretty easy because we know it's right out of the protocol for dopamine. The initial dose is 5 micrograms per kilogram per minute. So let's start working this out, and we're going to do it the long way first, then I'm going to show you a shortcut. So let's work it all out. 100 kilogram patient times 5 micrograms per kilogram per minute is going to equal 500 micrograms per minute. That's my desired dose. How do I get there? Well, I need to figure out how many drops. So we need to find an appropriate drip rate to deliver that dose. Our bag of dopamine happens to contain 400 milligrams in 250 mils of fluid. We could figure that out by doing some math, figuring out how much dopamine is 1 milliliter of fluid, and we'd be figuring out the concentration. We did all this in the last module when we figured out some concentration stuff. Or an even easier way is just look at the bag, because the bag actually says in the bottom right hand corner there 1600 micrograms per milliliter. So if you examine your drugs, and in this case your bag of dopamine, the answer's already there. So smart medics will do a little bit of reading and save themselves some math. Alright, so we need to figure out the drip rate to deliver a dose of 500 micrograms per minute of dopamine. And here's the long math. 500 micrograms per minute divided by 1600 micrograms per mil is going to equal 0.3125 milliliters per minute. It's an ugly number, but like I said, I'm going through this the long way first. Continuing through, 0.3125 milliliters per minute times 60 drops per mil, because I'm going to use a microset for this, is going to equal 18.75 drops per minute, or approximately 1 drop every 3 seconds, because we can never get exactly perfectly 18.75, or going back to the previous example, 1.6 drops. You're never going to get that exactly perfect. Unless we start using pumps, we're not going to get it exactly perfect. But 1 drop every 3 seconds is pretty close. Now let me show you a shortcut, because doing this kind of math in the middle of a living room is probably going to get your head spinning a little bit. A shortcut. What is the drip rate to deliver a dose of 500 micrograms per minute to that 100 kilogram patient? Let's create a quick little chart to help us out. And you can draw this little chart in your protocol book right now, or wait until I'm done. Whatever you like. And this will help you out. Here's the little chart that I wrote. If you had a really good preceptor or a really good instructor in school, you already know this part. 1600 micrograms is in 60 drops using a microset. We know that. It's printed right on the bag. 800 micrograms is going to be in 30 drops. I know that. I can divide by 2. I can divide by 2 again, and again, and again, and again, and again. So do you see where I'm going with this? I've created a little chart here, and if you want to pause for a second and write this down, by all means, go ahead. I'm going to carry on though. I've created my chart. Now I can gather up and I can create any dose I want, and all I need to do is add up the drops to get there. You can do this for single strength or double strength dopamine. The chart is different, obviously. Make sure you're using the appropriate one for your dose of dopamine. But I can figure out the drip rate. What I will do, because I'm after 500 micrograms, I'm going to choose 400. I'm going to choose 100. And I'm going to throw away the rest. 400 plus 100 equals 500 micrograms. And all I need to do is add up my drops. 15 drops plus 3.75 equals 18.75 drops. That's the same number I got last time, or 1 drop every 3 seconds. There we are. The easy way to do dopamine. Don't forget that one. So there you go. We've reached the end of our medical math pre-course. A review for PCPs and ACPs too. Everybody can always use a good review. Right now, in preparation for your certification day, there's a short quiz to do on the website right now. So by all means, take what you've learned here, or hopefully what you already knew and I just reminded you of. Go ahead and do your quiz. And by all means, good luck on your certification day.